Okay. लाईव्ह वरती अजून दिसत नाही बहुतेक.
Icon.
स्टार्टेड. लाईव्ह पण स्टार्ट झाला आता.
Okay.
स्टार्टेड. लाईव्ह पण स्टार्ट झाला. ओके.
Yes, alam ka.
Yes, fine. Okay, so today's topic is NAT, Network Address Translation. Now, first thing why we need this NAT concept. So what are the requirements? First, we will see that part. Okay, let's say this is my office. And
Just to confirm, your screen not visible.
screen not visible.
Video YouTube live also.
चालू आहे.
नाही दिसत आहे.
आता दिसतं. ऍक्च्युली थोडा डिले होतोय बहुतेक.
नाही डिले पण नाही, म्हणजे जो चालू केला ते पण नाही दिसत आहे ना. फक्त तुमचा कॅमेरा दिसतोय, पण जे तुम्ही शेअर केलं कंटेंट ते नाही दिसत. मीटिंग मध्ये दिसतंय पण युट्यूब लाईव्हला नाही.
युट्यूबला दिसत नाही. ओके. लेट मी शेअर द स्क्रीन. Okay. Now, can you see the screen?
Yes.
Okay, fine. Okay, so here we have this office router, and these are the users. This office router is connected to ISP router. And on the interface between ISP and office router, that IP address is always a public IP address. Okay, so public IP address is say 12.12.12.0/30. So on one side it is configured 1, and on other side it is configured as 2. Okay, so this is the complete internet. Okay, now inside my office we are using private IP addresses. Now we have different classes, class A, B, C, and from those classes we have the range. For example, for class C 192.168.1.0, we can use this network inside our office. Okay, so this is the private network. Okay, now let's say this user, say this is PC3, and this PC3 has IP address 192.168.1.3. Gateway is configured, say gateway is say 100. Now this PC3 user, he want to access a website hosted on internet, and IP address of that is say 100.1.1.1 slash something, say slash 24. This is the IP address of the server. Now, how the packet will be generated? What will be the source IP address? Source IP address will be 192.168.1.3, and destination IP address will be 100.1.1.1. This will be the packet generated by that PC3. Now this packet will be sent by PC3 to its gateway. When it comes to this gateway, now this router, if that router send that packet to ISP, if you configure some default route here, okay, ISP is not going to receive it. Okay, it will be just dropped. ISP is not going to process it because ISPs will never receive the packet or process the packet if the source IP address is a private IP address. It can be any private IP address from class A, B, or class C. But if that is from private IP address range, then ISP is going to drop that packet. This is the default behavior of ISP's routers. Okay. On the internet, you will always find only the public IP addresses, not the private IP addresses. Okay. So here we need a solution. This PC3 want to access that server on the internet, but PC3 is configured with the private IP address, and ISP does not entertain private IP addresses. So we need a solution so that this source IP address, which is a private IP address, that will be replaced with the public IP address. Okay, so when packet is transferred by router on this interface or sent on this interface, this office router will replace that private IP address with the public IP address, and then that will be transferred to ISP. Now ISP will process it. That server will send a reply. When the reply is sent from ISP router to the office router, again that router, office router, will remove that public IP address. Again, it will change that with the private IP address, and then that reply will be sent to the PC3. So this is how here we are replacing the private IP address with public IP address. And when the return traffic is coming, that public IP address is replaced with the private IP address, and PC can communicate with that server. So this is the concept, or this is where we need this network address translation. This is the most commonly used of the NAT, or network address translation. Okay. Another use is if you want to hide your original IP address. Okay, you don't have to connect to the ISP, but if you want to hide your own IP address while you are communicating with the other networks, then you can use the same concept. Okay, you can use some other IP address, and then the communication happens. So this is the use of network address translation, or NAT. Okay, any queries here?
No.
No queries. Okay. Okay, so let's see the technology here. Here we have this client 10.111. This is the NAT router on which this is the office router or NAT router. On one interface, this is the private network. On another interface, it is internet or public network. Say source IP address is 10.111, destination is 170.111. Okay, when this packet is sent by the client to the NAT router will change this source IP address. Okay, this is the private IP address that will be replaced with this public IP address 200.1.1, and that will be transmitted to the server. When that server send a reply, that server will send a reply to this IP address 200.1.1. Okay, this one, and then that packet will be sent to the NAT router. When NAT router receives that packet, NAT router knows that okay, this 200.1.1, this is for this 10.1.1.1. So mapping is there. So it will remove that 200.1.1.1 with this 10.1.1.1, which is the actual destination, and then that packet will be transmitted to the client. So this is how the IP addresses they are swapped by the NAT router. Now, when we configure NAT, there are a few terms that we use. The first term is inside local. Now, what is inside local? Addresses assigned to inside devices. So these are the private addresses. Okay, and these addresses they are not advertised to the outside. Means outside users they don't know about this IP address. They know something, some another IP address. Which IP address do they know? They know the inside global address. What is inside global address? Addresses by which the inside devices are known to the outside. Okay, these are the public IP addresses. So inside local addresses, they are private IP addresses of the systems, and inside global addresses, those are the addresses by which the other users they identify the inside machines. Okay, so these are the two terms that we use: inside local and inside global. Now there are two other terms: outside local and outside global. But at CCNA level, we are not going to focus on this. These are useful when you configure the dual NAT. Means both the parties or both the systems, end systems, they are hiding their original IP addresses. In that case, we need this outside local and outside global. Now, this is not covered in CCNA. So in CCNA, we'll be focusing only on the inside local and inside global part. Okay. Now there are three ways we can configure NAT. The first method is static NAT. Okay, so here we have inside and outside. We have these inside pieces with the IP address 10.111, 10.112. On NAT router, we are statically configuring the mapping. Okay, which IP address to use when the packet is received from this particular user. So, for example, the first PC with the source address 10.111, if router receives a packet with this particular inside local address, when the packet is transmitted to outside, the IP address used will be 200.111. So this is the static way. Statically, we are telling the router which IP address to use. Similarly, we can tell the router, okay, for this particular IP address, say 10.112, use this IP address 200.112. And normally, okay, theoretically it is okay, but for single users or the user who is just trying to access the uh, servers on the internet, we don't use this static NAT. Static NATs are mostly used to publish your internal servers so that outside users can access those servers. Okay, so I'll just explain the theory part first and then we will do the configuration. Okay, so let's go and configure this static NAT. So for static NAT, we have created this topology. Here, this is the NAT router. This is internet router, which has its network. This all part is internet. There is one server, server 3. IP address is 100.111.120, and on internet there is one user with IP address 100.2.2.10. Okay, so this is the internet part, and this is the NAT router. So this is inside. and this is outside. Okay, so inside you can have more than one interfaces. So here we have two interfaces or two networks. One is connected to fast Ethernet 0/0, one is connected to fast Ethernet 0/1, and we are using this network 192.168.10.0/24 and 192.168.20.0/24. Okay, so these are the inside networks. Okay, now say I have these three servers inside my LAN. This is server 1 or server 0, this is server 1, and this is server 2. Okay, now I want to publish these servers so that the user who's connected to internet, that user can access these servers. Okay, so which IP address has to be used by this user so that that user can access these internal servers. Now, what is the logic I just explained? On internet, public IP addresses, they are never used, but our servers has these private IP addresses. Okay, so we will tell the NAT router, or we will configure the NAT router in such a way that for this IP address, for this server IP address, that is 192.168.10.50, use the IP address 25.25.25.1. Okay, now from where we get these IP addresses. Now, if you want to publish your internal servers, you need to get the public IP address pool from the ISP. Okay, you have to pay charges for that. So let's say that ISP has allocated you the IP address pool. The range is 25.25.25.0 and subnet mask is 255.255.255.240. So here we are getting uh, 16 IP addresses which are starting with 1 and maximum is 15. So we have total 1 to 15 IP addresses in the pool. Okay, so out of that pool, we are telling the NAT router that for this server, we are going to bind it with this public IP address 25.25.25.1. For the second server, so for example 20.100, I'm going to tell the router that okay, you use this 25.25.25.2, and for the third server, which is 20.200, use the IP address 25.25.25.3. Like this, I'm going to tell the router that okay, these are the static entries. So whenever any user try to access using this particular IP address, for example 25.25.25.3, those packets will be sent to this server 2. If anyone try to reach on the IP address 25.25.25.2, okay, those packets will be sent to this second server. And if anyone try to reach on this 25.25.25.1, then those packets will be sent to the server 0. This is how the static entries, they are helpful to publish your inside servers or local servers to outside. So this is the logic, or this is the most useful case for the static NAT configuration. Okay, any doubt here?
No.
Okay. So let's configure this now. Okay, so nothing is configured. The configuration is empty. I have just configured the IP addresses on the interfaces. Nothing else is configured. Okay, so on fast Ethernet 0/0, we have this IP address configured 10.1. On 0/1, it is 20.1. On the serial interface, IP address is 12.12.1 with /30 subnet mask. And okay, nothing is configured except this NTP server. Then if you go to ISP router, Okay, IP address are configured on the respective interfaces, and nothing else is configured. It's blank. So first we'll start with the internet router. Now here we are ISP as well as we are the client, so we have to configure both sides, both routers. Now I just explained that ISP assigns a pool to the client. So ISP has to add a route into its routing table for the assigned pool. So ISP has assigned this pool 25.25.25.0 with subnet mask 255.255.255.240. So on ISP router, I need to add one route for this. Okay, now why we need this? Okay, on NAT router, when we configure a statement, say for example, for this server 10.50, use the IP address 25.25.25.1. Okay, so this router, NAT router, is going to replace this IP address with this public IP address, and that packet will be sent by this NAT router on this interface to ISP router. So ISP is receiving the packet with the source IP address 25.25.25 dot something. Okay, so if the static route is not configured on ISP router, okay, ISP is just going to drop it. Okay, for that we need to configure a static route on ISP router. So let's do that first. So go to ISP router, go to global config mode, then IP route 25.25.25.0 and subnet mask is 255.255.255. Okay, before I configure the static route, let me show you the routing table of ISP router. Then I will add that route, static route, dish IP route. Okay, so it is just showing three connected networks. Now let's configure the route. IP route 25.25.25.0. Subnet mask is 255.255.255.240. Okay, and router is going to receive the packets on interface serial 0/0/0 serial 0/0/0. Okay, so this entry has to be configured on ISP route. Okay, now if you check the routing table, it should be route. Okay, I got this entry here. Okay, it is statically configured. Fine. So ISP part is now done. Now let's go to the NAT router. Now when you configure NAT, there are few requirements. So which are the requirements? First requirement is on NAT router, you need to configure default route. Now here we are connecting our office to internet for browsing purpose. So that is why we need a default route. Okay. Then second requirement is we need to configure or we need to tell the router which are the inside interfaces or NAT inside NAT interfaces and outside NAT interfaces. Okay, and then we need to configure the NAT statements. Okay, so first we'll start with the first requirement. That is, if I check the routing table of NAT router, okay, only three net connected routes are there. Let's go to global config mode. and configure the default route. IP route 0.0.0.0 means for any unknown network. 0.0.0.0 subnet mask can be anything unknown, and I have to send the packets on interface serial 0/0/0, or I can configure the next hop IP address, that is 12.12.12.2. So here I'm using the exit interface. Done. Now if you check the routing table, okay, I got the entry S star. S star means what? S means static and star means candidate default. Okay, so default route is now added. Okay, now which are my inside devices and which are my outside devices? So sorry, outside interfaces. So the first interface is FA0/0. This is my inside, and FA0/1. This is also inside, and the serial 0/0/0 is outside. Okay, so let's go to that interface. Interface FA0/0 IP NAT inside. Then interface FA0/1 IP NAT outside. And then interface serial 0/0/ sorry, my mistake, it's inside. Interface serial 0/0/0, and this is IP NAT outside. Done. So we have told the router that which are the inside interfaces, which is outside interface. Then we need to configure the IP address pool that ISP has allocated us. Okay, so that has to be configured in the global config mode. So for that, command is IP NAT pool. Then you can configure or any name, say my pool, IP NAT pool, then the name my pool. Then you have to enter the start IP address. Now, what is the start IP address here? 25.25.25.1. Then you have to enter the end IP address 25.25.25.15, and then you have to enter the keyword net mask, and then the actual subnet mask given. So 255.255.255.240. Okay, so this is the way to configure the pool on the NAT router. Done. So my pool is now configured. Now I'm going to add the static entry for the server 0. Okay, how to configure that? IP NAT. Now what I want to NAT? I want to NAT my inside address. Okay, I want to NAT my inside address. Then I have to tell the source, which is the source. Now source here you can use list. List means access list. You can specify the access list, which should be bind to this statement, or you can add the static entry. Now here we are configuring static entry, so the source will be static. Now what is the inside server's IP address? 192.168.10.50, which is the IP address of the server 0. Now you have to configure the inside global IP address. Means what? The IP address from the pool. Now we have this pool starting with 1 to 15, so you can use any IP address from that. Okay, I will use the first IP address to 25.25.25.1. Done. So this will add entry on the NAT router. Now whenever NAT router receives a packet with the destination 25.25.25.1, those packets will be transferred to 10.50. Okay, So let's test this. Show IP NAT translations. This is the command we use to check the NAT configuration. Okay, now this is pro means protocol. Protocol currently there is no protocol here. If you connect, if any user connects to this server using say TCP, so there it will show the TCP protocol here. Okay, we'll see that part later on. Now inside global address is 25.25.25.1. Inside local address is 192.168.10.50. Now currently outside local and outside global, okay, it is blank. No one has connected or communicated on this server or IP address. Okay, so my NAT is configured, static NAT for that the server is configured. Now let's go to this user. Okay, first I will try to reach that IP address or ping that IP address. Ping 25.25.25.1. Okay, okay, I started getting the reply. Now if you go to NAT router and check NAT translations, you can see the outside local address, outside global address, and here protocol is ICMP. Now that laptop's IP address is 100.2.2.10. So here outside local and outside global, both the addresses are same because other side NAT is not configured. So here 100.2.2.10, this is the outside local and outside global addresses. And the inside local address is 192.168.10.50, and inside global address is 25.25.25.1, and protocol is ICMP because we have sent ICMP message. We ping from that laptop to that server. So we got this protocol here, ICMP. Now all these entries they're kept in the memory. Okay, there are timers for this. Okay, so timers we will discuss later on. So like this you get the entries. So after a certain amount of time, these entries are removed automatically. If there is no communication between this laptop and that server, after a certain amount of time, those entries will be removed. Okay. See, now ICMP entries they are removed, and only the static entries they are in the uh, NAT translation table in the NAT router. Okay. Now if I go to laptop and access the website hosted at that server. Okay. Now to access the website on this server 192.168.10.50, again I have to enter the same IP address 25.25.25.1. Now this you have to tell the users which IP address to use when they are communicating. Okay, so here I have modified the page, so I got the entry. This server IP address is 192.168.10.50, and if I go to NAT router and check the translation table, okay, the protocol is now TCP and port number is 80 because it is accessing the website. Okay, so this is how the static NAT can be used to publish your inside servers outside. Okay, any doubt?
No, no.
No doubts? Clear?
Yes.
Okay, fine.
Yes, clear.
Okay, after static NAT, let's see the dynamic NAT. Now, what is the difference between static and dynamic NAT and when it is mostly used? Now, dynamic NAT is used when you don't want to publish any inside servers. Okay, any IP address will do when the packets are sent to the outside. For example, here we have these users, inside users, IP addresses are 10.111.112, and on the NAT router we have this NAT pool starting with say 125. Okay, so this pool is there. Now, whenever the packet is received or whenever the criteria for the NAT is matched, then the NAT router will pick the next available IP address, just like DHCP. In DHCP also we have the pool, right? In DHCP we define the range. Okay, we exclude the addresses which we don't want to publish or which we don't want to allocate via DHCP process. So we have a DHCP pool here. Okay, so in DHCP pool, say we have IP addresses say 101 to 150. So how DHCP works? It will pick the next available IP address and that will be allocated. Same way, here we have the pool of IP addresses for the NATing purpose. So whenever the packet is received and the criteria is matched, then router will pick whichever is the next available IP address, and using that IP address, packet will be sent outside. Okay, so here you don't have to tell the NAT router that okay, for this IP address or for this inside local address you use this inside global address. No, it is not required. That will be done dynamically. But here problem is, let's say you have say 15 IP addresses in the pool, 1 5, and if there are 15 concurrent connections, means 15 users, they are trying to browse this server, then all the 15 addresses they will be used. Now, if the another user or 16th user try to access the outside network, he don't have any IP address available in the pool, so that connection cannot happen. So for that we use the next, that is overload method. Okay, so normally dynamic NAT is used when you are just doing the browsing. Okay, when users they want to access or they are connecting to the internet only. They are not, we are not publishing any inside servers with this dynamic NAT. So this is the logic for the dynamic NAT. Okay, any doubt for this dynamic NAT concept? Practical I will be showing after this.
Okay. No, okay.
Okay, now these are the default timers. Now this is not in the syllabus. If there is entry for the DNS protocol or DNS, the default time in seconds. So after 60 seconds, that entry will be removed. For ICMP, 60 seconds. Then for TCP, 24 hours. Then UDP, 300 seconds. Okay. Okay, so let's configure the dynamic NAT. Now you can configure static NAT and dynamic NAT simultaneously. You don't have to remove those entries which you have configured for the static NAT. Okay, so I just want to keep this entry for this server. If you want, you can add the multiple entries to publish all these servers, inside servers. Let's do that part. Then we'll configure the dynamic NAT. So IP NAT inside source is static. So the source static IP address is 192.168.20.100, and I'm going to use inside global address 25.25.25.2 for this server. Then for another server which has IP address 200, I'll be using the third IP address 200. Yes, correct. Okay. Now if you check the route, So here we have 3 static entries for all 3 servers, and all 3 servers, they can be accessed from outside. Let's try it. So for 2, okay, the IP address is 20.100. So that user has accessed this server, server 1, and with IP address 3, 25.3, okay, it has accessed 20.200 server, that is this server. So all the 3 servers now, they can be accessed from internet. Okay. Now to explain the dynamic NAT, I have one server on internet. So this is server 3, and IP address of that server is 100.100.111.120. And I have these users PC0, PC1, and PC2. They are the internal users, and they want to access this server. Okay. So for dynamic NAT also, we have the same requirements. Okay, default route must be configured pointing towards the ISP. Then we have to configure inside interfaces. Then we have to tell, okay, this is the outside interface, and that IP pool must be configured on the NAT router. So these are the common requirements, no matter which NAT you are configuring, static or dynamic. So that part is already done, so we don't have to repeat it again. If you check the running configuration, you can see, okay, so fast Ethernet 0/0. Here you have this command, IPNAT inside. Here it is IPNAT inside, and serial 0/0/0. This is IPNAT outside. Then here we have the pool that we have configured, and the entries for the static NAT. And here we have the default route configuration. Done. Okay. Now for dynamic NAT, you need to configure access control list, and that access control list will match the intested traffic. Means what? How to configure ACL that will permit this network. Means what? I want to allow this PC0 and PC1 to access that server on the internet, but I don't want to allow this PC2 to access that server on the internet. Okay, this is my requirement. So I will create one ACL to match this requirement, and then in the NAT statement, I'm going to use that ACL. Okay. So how do we configure ACL? Okay, access list. So access list number say 1. I want to permit. Okay, now here you can specify the complete network, or you can specify the single host. Okay, so I'm permitting this complete network. So access list 1 permit the network is 192.168.10.0, and subnet mask is /24. So wildcard bits will be 0.0.0.255. So I'm permitting this. Okay. Okay, all others, they will be denied by default because of that implicit deny statement. But if you want to specify that, you can add that entry so that you will get the log, or you will get when you check access list details, then you will see that, okay, those packets are dropped, or how many packets are dropped. So I want to drop this 20 packets, and I want to deny this. Okay, so access list 1 deny 192.168.20.0 network. Done. So my access list is ready. If you want to check, show access list. Okay, we have these two statements, which is permitting and one is deny. Now let's configure the NAT. So IP NAT inside. I want to NAT the inside addresses, but what is the source of that? Source is the list. Okay, so whatever is permitted in this access control list, that will be my source, inside source. So list. Now which list? Okay, list number 1. So list number 1. And then we have to specify the pool. Pool. What is the pool name here? My pool. Okay, so what we are telling the router, okay, you do the NAT inside NAT for the IP addresses which are permitted in the access list 1, and for that you use the inside global addresses from this IP address pool. This is the meaning of this statement. Done. Done. Now, overload we will see later on. So first I'm explaining this dynamic ACL. So we are done. We are done with the dynamic NAT configuration. Now if you check FPNAT translations, okay, still these entries are there. Okay, those will be removed after some time. Now let's go to this PC0, which is the inside PC, and let's go to this browser. Okay, in the browser, enter the IP address of that server. It is 100.1.1.120. Okay, so this PC is able to access the server on internet. If I go to PC1, okay, it is 100.1.1.120. Yes, successful. Now if I go to this PC2, which is in denied network, okay, so 100.1.1.120. Okay, this PC is not able to access. Request timeout, we will get the message. Yes, it can't access. Now if you go to, yes, the request timeout, we got the message. If you go to NAT router and check show IP NAT translations, okay, so we are interested in these two entries, 10.10 and 10.20. Okay, these two PCs, PC0 and PC1, has used the IP address 4 and 5 from the pool. Why? Because 1, 2, 3, they are for publishing the inside servers. So those are the static entries. So those three addresses, they will not be used. So the next available IP address is 4 and 5. So for these two PCs, PC0 and PC1, router has picked those two addresses, 4 and 5. And here you can see the destination is 100.11.120 and port number is 80. Okay, this is the local port. This 1025 is the local port. And those are managed by the operating system. Okay. So this is how the router will pick the next available IP address from the pool, and using that IP address, my inside machines or inside users, they can communicate with the outside server. Any doubt?
No.
No, clear. Fine. Okay. Now after the dynamic NAT, we have the third type, that is overload. Why we need overload? Let's go to that topology again. Now let's say I don't have this IP address pool. Okay, I have just one public IP address. Okay, this must be the statically configured or static IP address, and this is the only IP address I can use to reach the internet or send the packets to internet. Okay, now there are multiple users inside, and I have just only one IP address of the interface. Now this is configured on this interface. This is not from the pool. Okay, so I'm going to use the IP address which is configured on this interface serial 0/0/0, which is a public IP address, and using that single IP address, all the inside users, they can communicate the outside or the internet. So when the packets are sent from this first PC0, say PC0 want to access that server, and it will use the IP address 2520, sorry, not 25, this time it will be 12.12.12.1. So it will use the IP address 12.12.12.1, and NAT router will assign some port number to this. Okay, some port number will be used, and then that packet will be sent to the ISP. When the second user comes in, it will use the same IP address 12.12.12.1, but it will use some different port number this time, and then that packet will be transmitted to the ISP. So here, NAT router is differentiating the traffic for different users based on this port number. Okay, there is only one IP address, but the traffic is separated by using these port numbers. Okay, so this is called the overload. This is called the overload method, means using only one IP address based on the port numbers, all the systems which are inside, they can do the browsing. Okay, so let's see this part, how to configure this overload. Okay. Now how to configure or how to publish your inside servers with overload. Okay, that part we will see later on, because that is not the part from the CCNA. The normal configuration I will show you. So to configure that, I need to remove all the entries from the NAT router, so I can clear those entries. Clear IP NAT translations and asterisk star. Now if I check the NAT table, okay, only static entries are there. Dynamic entries, they are removed. Once I remove uh, the static entries from the running configuration. If you check the running configuration, okay, I have these static entries for the NAT. Okay, so I'm going to remove all this. I don't want all these things now. Done. So now if I check the NAT translations, okay, nothing is there. Fine. So we'll keep the pool because anyways we are not going to use that pool. So let it be there in the running configuration. Access list, okay. We will use that access list. Let me configure the overload. So how to configure overload? Go to global config, IP NAT inside. Then I have to specify the source. Now for source, I'm going to use that list which we have just configured. List number is 1. And then instead of pool, I have to specify the interface of the public facing or internet facing interface. So here interface is serial 0/0/0, and after this I have to add this keyword overload. Okay, done. Now let's go to PC0. Okay, do show IP NAT translations. Okay, nothing is there. So let's go to PC0 and access this server again. So 120. Yes, I'm getting the home page. Now if I go to NAT router and check, yes, 12.12.12.1. This was the inside global address and port number used is 1026. Now if I go to PC1 and from there if I access the same website, now if I check the NAT table, okay, now the port number is 26. Okay, for inside global address is 12.12.1. Now instead of accessing that website, if I ping this IP address 100.1.1.120, so I'm able to ping. Now let's see which ports are used by NAT router. Okay, so for ICMP, it is using this 1, 2, 3, 4 ports, and the protocol is ICMP. Like this, these users they are able to communicate with this server. Now in the access control list, if you check, do show access list. Okay, 16 packets are permitted and 12 packets are denied for this. So if I go to PC2 again, which is in the denied network, 20 network, and if I try to ping that server, ping 100.1.1.120, okay, request timeout. Okay, now go to NAT router and check this. Show IP NAT translations. Yes. 20.10. Okay, there is no entry for 20.10. Okay, we have entries only for 10.20 and 10.10. And if you check the access list, it is denied. 16.16.99. Here it was 12 matched for this 20 network. Now the match count is increased 16 because this PC has sent 4 packets, ping packets. So this is how we can configure the dynamic NAT with overload or overload. So this is all about the static NAT and dynamic NAT and uh, overload. Now this is also known as port address translation. Okay, so NAT with overload is nothing but the port address translation PAT. Okay, so that's all for today. So I'm ending the YouTube session now. You can wait.